Today we will see one derivation which is asked in Mumbai University and Nagpur University as well on numerical aperture, and we will also see a few numericals which are asked in the exam. First of all, I will show you the questions which are asked in exam. Question number 1 is derive an expression of numerical aperture for a step index fiber. This question is asked in Nagpur University and RTM Nagpur University and Mumbai University as well. In RTM University there is one subject in 7th semester, optical communication. This question is asked under this course, and in Mumbai University engineering physics 2 is a course, and the question is asked under this course. And here I am also going to cover this numerical which depends on the derivation of numerical aperture. Let us start. Numerical aperture of optical fiber. As in this figure, as you can see, this is an optical fiber. This is the core, and this outer is a cladding, and this is the fiber axis. This is fiber axis. Right now, this is air. This medium is air, and core is having a refractive index of N1, and cladding is having a refractive index of N2. And here you have always remember that the refractive index of core is always greater than the refractive index of cladding. Now here a ray is entered from air into core with an angle of theta A. Theta A is an acceptance angle which is called as acceptance angle. This ray is entered from point A into core. Now here we are giving this point B, and then after striking here core cladding interface, this ray will get refracted again into the core. Here we are considering this angle as theta R, and this is theta C, that is critical angle. And as here you can see, there is a here there is a right angle triangle, and here also there is a right angle triangle. So here as we know this angle is theta C, so here this angle we can find out easily. This angle is nothing but 90 minus theta C. This is 90 and this is theta C. So it is 90 minus theta C. Now here first of all we will apply Snell's law at point A, that is air core interface. We will apply applying Snell's law at air core interface. This is air interface, this is air, and this is core. So here we are applying Snell's law at air core interface. Snell's law is nothing but the refractive index of one medium, that is the refractive index of air is N0 into the sine of angle, incident angle. This is theta A. So here we are taking N0 into sine theta A is equals to refractive index of core into this angle theta R, sine of this theta R. So it is N0 sine theta A is equals to N1 sine theta R. As we know that theta R, this angle and this angle is same, as it is taking a Z shape. So this and this angle is same. So theta R is nothing but 90 minus theta C. So here we are replacing theta R by 90 minus theta C. Now as you know that sine 90 minus any angle is cos theta. So it becomes N0 sine theta A is equals to N1 cos theta C. So easily we can find out theta A. Sine theta A is equals to N1 upon N0. This N0 will goes here into the denominator. So it is N1 upon N0 into cos theta C. Give it as equation number 1. Then as we know that as per trigonometric, we know that sine square theta plus cos square theta is 1. So cos square theta is equals to 1 minus sine square theta. Now here we want to replace this sine theta C. So cos theta C. So it is cos square theta is equals to 1 minus sine square theta. So if we take under root of it on both the sides, then we will get cos theta is equals to under root of 1 minus sine square theta. Now let us replace this cos theta c by this under root of 1 minus sin square theta c. Now the angle is theta c, so here we are replacing this theta by theta c. So substituting equation number 2 in equation number 1. Then after substituting equation number 2 in equation number 1, we will get sin theta c is equals to n1 upon n0 into under root of 1 minus sin square theta c. Now again we are applying Snell's law at core cladding interface. Apply Snell's law at core cladding interface. So here we are applying Snell's law at core cladding interface at point B. Now we are applying Snell's law at point B. Point B is here. Here we are applying Snell's law. Here this medium is our core medium and this is cladding. So we are applying Snell's law at point B. So the refractive index of core is n1 into this angle is theta c. So n1 into sin theta c is equals to n2 into this angle. At B there is 90 degrees, so it is on right hand side n1 into sin 90. So the equation is n1 sin theta c is equals to n2 sin 90. n1 sin theta c is equals to n2 sin 90. As we know that sin 90 is equals to 1. So n1 sin theta c is equals to n2 into 1 is n2. So sin theta c is equals to n2 upon n1. So give it as equation number 3. Now here we are substituting equation number 3 into equation number 1. This is our equation number 1. So we are substituting sin theta c is equals to n2 minus n1 into this equation. Sin theta one sec. Sin theta c. Sin theta c 1 sin theta a. Here we are substituting equation number 3 into equation number 2. We are replacing sin theta c by n2 by n1. Equation number 2 is, this is sin theta c. Here we are replacing it. This is equation number 2. We are replacing it by sin theta c by n2 by n1. So equation 2 becomes sin theta a is equals to n1 by n0 into under root of 1 minus n2 by n1 whole square. So let us solve this. N1 by n0 into under root of 1 minus n square upon n1 square. So cross multiplication, n1 by n0 under root of n1 square minus n2 square upon n1 square. If we take this n1 square out of this root, then we will get n1. So n1 upon n0 into n1 under root of n1 square minus n2 square. So n1 will get cancelled and it is 1 upon n0 under root of n1 square minus n2 square. As we know that refractive index of air is 1. So sin theta a is equals to, here if we replace this n0 by 1, then sin theta a is equals to under root of n1 square minus n2 square. Now this is nothing but, this equation is nothing but our numerical aperture. This is called as numerical aperture. So the numerical aperture will be sin theta a is equals to n1 square minus n2 square. Now this equation is mostly asked in the exam, and there are numericals which are asked in exam, and this formula is applicable into the numericals. So finally we got the numerical aperture, that is equals to sin theta a is equals to under root of n1 square minus n2 square.